in this computer. Cool. So this is your assignment from what I'm aware of, at least. And this is the first time I'm reading it, so we'll sort of go through this together. The first part is to create your algorithmic space using processing, and this is just a 2D floor plan. And okay, so it can be, a series of randomly oriented lines or a grid or circles, and you should have intention and an idea. Okay, so we're going to use processing to export a PDF so that we can import it back into Rhino and Grasshopper. And so part 2 is your parametric structures. So the first step will be to obviously import your PDF that you created using processor back into Rhino. Okay, the second step will be to design and create a roof structure to cover or partially cover your floor plan. And the roof may vary in height and may extend beyond the edges of your plan. Okay, so that's okay. So the roof structure must be supported. It can't just be floating, obviously. So we're going to create a structural system as well. So yeah, so think back to the parametric truss. I'm assuming you guys already did this assignment, so you should have an idea, and we'll go over that slightly, maybe, if we have time. And a panelized enclosure system. So this is, I'm assuming, the wall that will sort of like surround your floor plan. Minimum of 50 panels. Okay, that's pretty easy. And yeah, so that looks good. So in this tutorial, what we'll do is sort of cover part 1, and we'll touch upon a little bit of part 2, namely just this first part, importing and sort of extruding your geometry in Grasshopper. So for this first part, we're going to be in processing, and I will show you an example of something I created back in 2018. And yours can look different, obviously, and this isn't really a good example, but I have here like some walls, and they have openings, and yeah, so the walls are, the rooms here, if you could define each space as a room, they're not fully like completely closed. There is a way to get in and out. So that's important in your script. You should make it so that if you do generate the things randomly, that the spaces are sort of, traversable, like you can go through. And cool. So I'm not going to like go over my script. What I am going to go over is how to sort of output a PDF from the image. So let's say your script runs and you have this, right? And in this example of my script, I'm not using the draw function or method, because my script isn't animating. It's just running once. You could, set your, I think there's a flag you put into setup so that the draw function only runs once. But instead, what I used was I just created my own function called do work, and I just called it once from the setup function, which makes it so that my code only runs once. Okay. And in order to export the PDF, the first thing we need to do is import the PDF package from processing. So you just type in import. By the way, is the font size too small? Can you read it?
It's fine.
Okay, great, thanks. So import processing.pdf.star, and that will give you access to the methods we're going to be using. And the first one is called begin record. And you want to put this line before your code starts. So this should be the very first basically line of code before you start drawing. You can put it after size and background, that's fine. But you need to put it before you actually do your drawings. And so this method takes in, like the first parameter is PDF, and the second parameter is your file name. And if you put in like 2 hashtags, then what you can get is like a file name that changes. So it increments each time you run it. But since we only want one file, really, I can just call it, let's say, output.pdf, so that it will output my drawing into a single file every time I run it. So then I do the work, which is basically calling this script, and it runs through a bunch of things. It's got a for loop and a while loop and another for loop and a few more. And I think what it does, it just draws a bunch of lines vertically, and from the starting point and the end point of each of these vertical lines, it draws some horizontal lines until it reaches the other line, basically. That's all it does. It's just vertical and horizontal lines. That's good. But then what you need to do after is call end record. And what this will do is it will basically save the file. So when you call this line, it just keeps drawing, and then when you call this line, it ends recording. So if I stop my script and run it again, and we check the folder that our sort of script is placed into, it's this one here, but it's not this one. It's this one here. So this 00 came in from before, so I'm just going to delete that. But output.pdf is our file, and it just contains what we see here as a PDF. And in Rhino, when we open up Rhino, you can simply just drag and drop it into Rhino. So just like that, import file. And there's going to be a few sort of, I guess you don't really have units in processing, so you can just let it do its thing, hit OK. And that brings in your curves as actual Rhino curves. Then when you open up Grasshopper and you, again, import these curves as curves, just like this. So since there's more than one, we have to use set multiple curves. We can select all of them, except, you know what, that's fine. We can do that one as well. So once you have that, a few things you can do to sort of add thickness to your curves, because when you draw in processing, it's usually generally going to be just like lines. Even though these have thickness, they will appear as, even if you add a stroke width, they will still appear as a single line. Does that make sense? Okay, so we need to add thickness to this wall. Like if we just extrude it up, it'll just be like a wall of like 0 thickness or something. So extrude. So we can use extrude, and direction will be unit Z. Whoops. That's direction, and the base, that's a curve. And we can put in a slider here. Okay, so that's our extrusion, but then we need to add thickness to these walls. And the best way to do that, I don't think there is a thickness component, but you can do is extrude again, but this time along the normal of the plane. So this gives you basically planes, right? If you think of each one, they're just flat. So just want to make sure to get the normal, we can call evaluate surface. And the surface will go, so extrusion will go into the surface, and we need to make sure to reparameterize. What if your walls are curved? Same thing. If your walls are curved, then it will still get the normal, and it will get the normal at the center and try to extrude it. Good question. Let's see if that works. What we can also do is, yeah, we'll assume that we'll make one of these curves curved, so we can run through that. Yeah, so if you create random stroke with weights, they will not appear when you export PDFs. Actually, maybe they do. Let's find out. I think I had a stroke weight here. Yeah, so I did have a stroke weight here of inner wall, and the inner wall, it's not 0. Yeah. Yeah, so it won't appear in Rhino. It's been a while since I used processing, so I might be misremembering, but I do have a stroke weight set here in my code, and it didn't appear in my Rhino file. So I'm assuming you can't. You can add offset. Yes, you can add offset. I think offset surface is the other command. But I think this won't give you 3D geometry, will it? Let's say. Okay, so this gives you an offset, but it's not going to connect the geometry for you. But there is a script sort of here. Let me just see if I can find it. Does anybody have any questions about the assignment so far, or in general?
I think in Brady's code, he was using like call duplicates for his code, and I'm just trying to understand like when would we need to do that?
All duplicates. So if the script, if your like curves are like overlapping, then you would need to sort of make sure there are no duplicates in there. That's when you would use call duplicates to get rid of like any overlapping curves. If that makes sense. You can also, if you say you have a duplicate, make a copy of this. So now if I click on this, it gives me 2 options. So that's a duplicate. You can also type in cell dupe in Rhino. That will select any duplicate curves. You can just delete them, and then you wouldn't have any duplicates. I think that's what he meant by cell dupe or cell duplicates.
I think Ria has a question. Go ahead.
Evaluate surface.
Hi, I was wondering, I don't know about everyone else, but like even though I did the first assignment on processing, I was still kind of lost when using the software. I wonder if you have like a recording of like a tutorial on processing, or if you can like go over it.
I just added a YouTube link to the processing intro. It's on ALD's YouTube. You can check
I did this one too. Well, yeah, we do have a simple processing tutorial, I guess. I don't think I have time to do another processing tutorial today, unless everybody wants to see that. I think today is mainly for sort of like questions about your assignment and how to do certain things. For example, how to add thickness to curved walls, which I am having trouble with. Let's see if this works. Okay, I'm going to try just one curve. Mo, how would you add thickness to a curved wall? Wouldn't you just use evaluate surface on the wall?
Yeah, that's what I used. That's pretty sure I remember.
Yeah, so it does. No, it kind of. What am I doing here? Create a extrusion first. Then I'm going to add a thickness. Yeah. And that will give me a. So what happens if I rotate this curve?
Oh, it's a doubly curved mold, right? That's why I guess.
Yeah, so it's doubly curved is a little bit difficult. So if I have like a really weird sharp angle like this, then the extrusion doesn't really work. But what you can do is, I guess, if you enlarge the Grasshopper window, I mean this. I could enlarge this, but you really don't want to see any of this, trust me. I just opened it up to see what I did to extrude walls. It's easier when you have like these situations where it's simple, but when you have a doubly curved surface, like when you have like a curved surface and you want to extrude it, the best way to do that would probably be to offset curve. So we'd have this curve, we'd offset the curve, and then we'd take the endpoints. And then take the endpoints of this, and then take the endpoints of the original. Okay, so let's do this from scratch. So if you have a curved, let's say curves like this, and you wanted to add thickness to it, what I would do is start with the curve, import it into Grasshopper, then offset the curve depending on the thickness. So let's say this goes to like 30 centimeters. I'm assuming our units are set to meters, which they might be. Yeah, so our units in Rhino are set to meters, which means these are also meters. So 20 centimeters is the distance. So that's the wall. And then I would take the endpoints. So that's over here. And I'm just going to make this a bit bigger. So we have our endpoints here. We have our endpoints here. And you just connect them using a line like this and this. So that's the starts, and the ends will go from here to here. And then you just join all the curves. So join curves located here. And we'll just connect all of the curves to this. So at the end of it, we'll have like a solid curve that's like uniform thickness all the way throughout, no matter how you sort of rotate it and orient it. Maybe if I make the thickness a bit thicker, it'll be easier to see. Then you can do an extrude. So after you basically add thickness to your 2D curves, you can extrude and cap later along the unit Z. So just making sure to organize my code. So these are the two endpoints. These are the together, and that's the offset, and then I join them. So all of this is to create that thickness, and all of this is to add 3D depth. Let's say this wall is 4 meters tall. So unit Z, 2 direction, and then extrude. That will give me a thickness here, and then I need to cap it, and object contains 1 error. Okay, that's fine. I think I may have selected the wrong thing. Oh. For some reason, these join curves is giving me 2 curves. Why? Is this not joined? Interesting. Okay. Do apologize. Don't know what's going on here. There is 1 curve coming in, and it's being offset. Then I'm rebuilding that curve. It should be. Yeah, maybe I will look into that later. Does anybody have any other questions? So whoever had that curve question, I will get back to you. Extrusion worked. Mo, do you know what's going on here? What I'm doing wrong? Why are there 2 planar curves when I joined
Yeah, I'm actually trying to figure it out.
this
I'm doing it.
and this? and this.
You have to flattening them. Have you want to try flattening?
Oh, I mean, thing is, they're all same thing.
No.
Yeah, guys, I have no idea what's going on here. This is really weird. Two curves. It's probably something super simple that I'm just missing. These curves are joined. It's like that. Oh, you know what it is? It's the order. I think it's the order. No other questions? Just everybody's watching me struggle with Grasshopper. Could you do an example for the part in the assignment that said design a structural system? I think I have an example of this on the YouTube already where you design a parametric truss, but I'll go over that very soon. I'll go over that example. Yeah, I just want to try one last thing about this curve thing. So we have the first curve, then we have one of the endpoints. This gives us, okay. Then we'll do the other curve, the other final endpoint. Still two planar curves when I joined them. Yeah, no idea. Come back to this. So now going over, like, let's say you have a let's say this is like a surface we're going to create with a loft. So this is your surface, right? This is for your roof. Is that visible?
It's good now.
What I would do is, so I'll bring in that surface, or if you were using Grasshopper, you would already have created that surface in Grasshopper. And then we'd sort of split it up. So let's say we have this many segments. Yeah, so this is your divide domain squared, right? And you have U count and V count. We're going to keep U count this like 0 to 1, and V count we can increase it to how many trusses we want. So these are the vertical lines that you see. I'm just going to hide that. So these lines will sort of act as the chords of our truss, and we can move them down to basically this is the top chord. If you imagine this line being basically the top part of a truss. But first we need to keep rep. Then we get the edges and connect it to the geometry. We would move the geometry down. So we'd use unit C, and we'd use a slider that goes from some -10 to, let's say, 10. And we would connect this to, yeah, so -10 is a bit too much. If you look at the slides, oh, one more thing is it's selecting the edges that way too. So to isolate just these longer ones, there's a few things you can do, but I think if I just choose the correct index, I will get the vertical lines only, and it seems to be the 0th index. So these edges give you like a rectangle basically, and I'm only taking the vertical one. So I'm just using list item to get that. And using this list item and that, I have basically the bottom and the top of my truss. Then I can divide curve, take this curve, and let's say we want to have, how many vertical, like diagonal members do we want? Let's say like 20 or 200. Connected to count, that's too many. Divide that. So this time I'm using divide curve again for the bottom curve, and we're going to use the same number slider. Yeah, so if you watch the tutorial in the chat, it basically teaches you how to do what I'm doing right now, is creating a truss. And then, yeah, I'm not going to go through the rest. Actually, I might just do the simple lines here just to show how the points connect. I won't go through the diagonals because it's a bit more complicated. But yeah, so if you imagine these are your like trusses and we bake them. One second, I just gotta do something. Sorry about that. So then if I show the curves, and I don't know where my curves disappeared to. Did I not bake them? This and this. Okay, so then I have curves, sort of these trusses, and you can add thickness to them, and that would be your how you would connect your parametric like sort of roof, which has curvature, to the trusses that will support it. There are other ways you can do this, but to get the curvature on the wall, you'd use your divide domain squared, then your isotrim, then your deconstruct to get the curves here, and then you do the list item to just select the single curve. Okay, hopefully that's clear. Okay, any other questions?
There's one in the chat.
I may have missed it. Which one is it?
So can you go over? I think you just talked about it. Yes.
I've talked about the truss one. I think there's one here says how to create thickness for a closed image like a circle. So from your processing script, I'm pretty sure you wouldn't create a closed circle. Let me just, okay, no, you can make a fully enclosed. Okay. Yeah, so let's say you have a circle, right? Thickness, you'd use the same way. So if you had a circle and it came from your processing script, you do the thickness in the same sort of way as you would with the curved, which we're trying to do here, but let's just do it for the circle. So it might be simpler because it's just one curve. So we're going to set that curve. In reality, you would have maybe multiple curves, and you would offset the curve a certain amount of distance. So the distance will be like how, wait, not this, it's here. Just going to move this slider over. So this is your curve that's here. This is your offset curve, and you choose the thickness of it and using a slider, then you'd extrude it. That's your base. Unit C is the direction. And the height of it is, again, another slider. And finally, you'd need to also extrude the other curve. So this one. So I'm going to drag both of them in and cap everything at the end. Actually, No. There's a better way. Boundary surface. So once you have your two curves, you want to first create a surface between them. So just connect the edges together before the extrusion. And we want to make sure this is flattened. So once it's flattened, for each of your curves, you have that surface here, and then you can do the extrude. So there's a step. So you don't do the extrude first, you do it after you get that surface. And now we're just extruding that surface. So we don't need a cap at the end, and it will give you a sort of closed solid. So if we bake this and look at it in Rhino, it's just a solid cylinder. Okay, another question is, okay, we went over connecting the roof to the wall. Okay, so how do we connect the roof to the walls? Same way, I would do the same way. You could just get, say you wanted like walls all along your roof, you would just debrep the roof. So if we go back to our surface here, let's hide everything. You can debrep it right away, and that gives you the edges here. That are the edges of the surface, and you can project it. So curves will be the edges, and the brep will be basically the ground plane. And to get the ground plane, you can just do XY plane, I think. Yeah. Direction is by default down. Wait, this is not the right project. This one, sorry. So this one that has the plane as its input, that's the project you want to use. This one will project it to another brep, but a plane isn't actually a brep. It's not a boundary represented object. So we'll delete that. We'll use this one. So it just takes in the geometry, which is your edges, and it takes in the plane where you want to project onto. That gives you like a flat thing right there. And you can just loft between these two. So loft between the edges here and that, and not like that. Okay, that's the curves. These are edges. I need to join them first. We shouldn't need to. Let's see if join curves will join these. Okay, I haven't had much luck with join curves lately. I don't know why, but this one seemed to work. So before there was like 4 separate curves, I just joined them into basically one continuous curve, and then I can loft between these to create a wall condition, and that's your roof. So you could do it that way. It's up to you. You can also add like an offset. So once you have this wall, you can offset it outwards or inwards to have your walls be wider or smaller than your roof. So where did this come from? Yeah, so to add a wall, we just sort of deconstruct the brep, take the curves that you got from the deconstruct, project it downwards. So project it downwards, then join the curves, and then loft them. But I think this is already, yeah. I hope that was that answered your question. Does the truss have to be directly on top of the extruded curve? Not sure what you mean by that, but if you mean like the trusses here, if they have to be directly on top of the curves that you extrude from your processing script, the answer is yes and no. It's up to you. but the trusses have to sort of be supported on something, right? So you can use pillars, and you just connect like one of these, maybe the endpoints and maybe a point in the middle, or just the endpoints to like a point on the ground, and you connect them with a line. They have to be supported. If you wanted to, you could support the trusses onto your walls that you extrude. That could be a possibility. So yeah, it's up to you how you connect that. So the person asks, I'm not sure if you showed it, but already, but I'd like to ask you a question. Once we make a floor plan in processing, can we make it so that processing it can make so many elements? How can I use only a few elements I want? I'm not sure what you mean by that. Once we create, sort of, we create a floor plan in processing, and we stop when we like what we see, right? And it shouldn't be animating, but if it does, is that what you're asking, Yagmur? Like if your sort of script is animating and you want to stop it somewhere you like, and you just want to use those few elements, because the other option is just deleting certain geometries in Rhino. Like if I don't like this part of it, I can just delete it. Maybe ask a follow-up question if I didn't answer that question of yours. Where will this video be posted? It'll be posted on the YouTube channel sometime, I think. Yeah. How can we use random to make the surface panelization interesting, or just give us some interesting panelization ideas? So the surface panelization, it's up to you. You can use random. You can create a bunch of like openings and use an attractor point, and or maybe have like different variations of like height, and it's up to you how you make the panels. I really don't have any advice other than that. Sorry, I had a final exam at like 9 a.m. today. Will elements that have the same color as the background in processing show up in Rhino? No. The background does not show up in Rhino. Wait, so okay, wait, no, yes, I think I understand your question. So you're saying if you draw something in processing that's like, let's say, white, and your background color is white, they will still show up in as curves in Rhino, because what the PDF does is it exports curves. So if I find that folder again and I open up that PDF, wherever that folder is, yeah, so that's the thing. You should only draw what you want. So each of these is like a curve I can edit. I can like select. So even if your curve is like, okay, it's not letting me for some reason. It only lets me touch this one. But if your curve is like white, it will still appear as a curve in Rhino. So you should, if you're like coloring it in white to sort of hide it, you should think of a way to sort of not draw that curve at all and still get that effect. Yeah, I know what you use white lines to dissect your curves. So what you should be doing is the curve that you're dissecting, you should like sort of find the point and draw it until that point, and then like draw the so the two curves that you get by cutting your curve, you should draw those curves separately. Yeah, so you won't be able to basically get an opening by drawing like a really thick line through here. And if you bring it into Rhino, you will still see that line. I haven't tested it, but I'm pretty sure that's how it will work. And feel free to try it. Just export the PDF and see if it shows up. It will most likely will. Okay, any other questions? By any chance, do you know how to make a spiral in processing? Spiral. I think that might be something that exists as a, okay, so it looks like what you have to do is this, but let's see what it looks like. Okay, it's just drawing a spiral, and that's not what we want. To answer that question, I do not know how to make a spiral in processing. I mean, yeah, there are ways you can, I guess, like draw points and move it, but you can also create your spiral in Grasshopper. Like if you define the, I don't even know how to do a spiral in Grasshopper, so I can't really answer that. Sorry. Yeah. Okay, I'm gonna go back to this and see if I can figure out why. Any other questions? Anything specific you want to learn how to do? Oh, no way. So there's already, oh, this is part of pufferfish, never mind. Okay. So I don't know. Mo, do you know if pufferfish is included in Grasshopper?
I don't think so. I don't think they're allowed to use it for this assignment.
Because this would make offsetting curves so much easier.
Yeah.
Because it offsets it and it caps the ends. So I was trying to do that here with this script by offsetting the curve first, and wherever that curve is. So by offsetting the curve first and then joining it, but for some strange reason, the curves just refuse to join. Preserve directions, false. Oh, that's what happened. Okay. So yeah, so I figured it out, guys. If you have this issue where, you're trying to join curves and for some reason they're not joining, it's because the directions were preserved. So just make sure this is set to false. So let's go back a few steps to this script which we were working on for offsetting and adding thickness to a sort of curved wall. So yeah, you do the same way, just make sure you have these in the right order and you flatten your inputs, but I don't think you should need to flatten the inputs. You don't really, no, you do need to flatten the inputs. Okay. Make sure you flatten your inputs to the curves. And when you join them, they will appear like this. Then you can use the boundary surfaces command, which is here, to add basically a surface to that closed curve. And then when you extrude it, so this is the surface we're going to extrude, and the direction will be up. So when you extrude it, it will become a solid wall. Okay. Yeah, so no matter how you sort of curve it, it's always like a solid wall, and it has a thickness that's equal, consistent. Okay. Is there a way of dissecting circles in processing where I would have to use arcs? You would have to use arcs because processing doesn't work with like Boolean difference or Boolean splits, unfortunately. So you just have to think of how you're creating that circle. You should use arcs and then stop it where you need. So you create an arc and you create another arc to create an opening. Is there a way to join columns or pillars to the parametric surface roof that we're making? Yeah, of course. Well, the parametric surface roof, say you sort of have it already and it looks like this, right? You can evaluate points on the surface that will give you a point. And if you project that point to the ground plane, then you have 2 points, right? You just connect them with a line and add like a pipe to them, and you get like a column that connects your surface to the ground. But that's not really a good way to do it. Instead, you should have some sort of like truss system on the surface, and then connect the truss system to the wall, to the ground. Instead of directly connecting the roof, you go through sort of like a medium, right? Because the truss needs to sort of be there as support, and that's part of your requirements. Is there a way to make our extruded walls from processing have some sort of varying form on it, like a varying height? Unfortunately, you cannot do that with like this method where you just extrude it. But what you can do is extrude sort of, yeah, it is a bit more complicated to add sort of varying height in the same curve. So if you have this one curve, right, and you wanted to sort of vary the height, it's way more complicated because what you have to do is move this curve up and manipulate each of the points so that it's like that or something. And then you loft between them and you offset the surface that way, or which
Sorry.
is, nope, go ahead.
Sorry, I meant thickness.
Oh, like thickness like this?
Yeah, like
you can definitely, yeah. So each one of these curves will be separate. So you just add some sort of attractor point or something that controls the distance here. So if you connect an attractor point to this distance input, then all of your curves, like each one of these will have a different thickness. Yeah, hopefully that makes sense. And I would go over attractor points again, but you can find that example in, I think, the last one we did. I covered attractor points. Yeah. You can also do the same thing with height. If you have these individual curves, you can change the height of each one with attractor points as well. And I think I did that here. Yeah, so each one of these, yeah, I guess I'll show you an example so you sort of know what to look out for. So this is the roof, right? So let's say this is the roof, and the roof had, so in my example, I don't think I added trusses. Yeah. So it sort of depends on your intention, on your intentionality. Because this roof system had its own sort of ribbed structure in it that I created. Like, so this is like enough support in my mind to be allowed to create columns, and there's lots of columns to sort of carry that weight. But if you were to connect just like 4 columns, right, into like a flat, like a surface like this, it wouldn't make sense. And you might lose marks for that. But this is the wall, this is the roof, and it connects to like pillars that's on the ground plane. So I projected those points down, and my sort of rooms here, they have the same thickness everywhere, but they have different heights that I created by using like an attractor point. Okay, I hope that answers your question. Is there something I think someone had a question I couldn't answer. Does anybody remember which one that was? Because I totally forgot. I kind of want to try it again. Yeah, any other questions that I didn't answer? So yeah, spirals in processing. Yeah, spirals in processing are very, very difficult. And I don't think you can do it with arcs. No, you wouldn't, because arcs have the same radius. most of these examples use like a translating, like a point that moves and draws the circle, but that's not that efficient. Yeah, so you have a radians, you have an x and a y, which it goes through a lot of like math and yeah. So I guess there is a formula for creating spirals mathematically, right? If you apply that formula in processing, you can achieve the same thing. Whether or not you want to go through that trouble and learn how to do that is up to you. Wow, this. Where's this x and y come from? Yeah, I'm not even gonna try. Yeah, so it's complicated to do spirals. Let's just yeah. I'm sorry. Yeah. Any other questions? If there are no more questions, I guess I can end. Okay, well, okay, Sophia asks, I tried doing a spiral for the first assignment and it was really difficult. The closest I got to using mathematical formulas for Fibonacci spirals, and I ended up using, okay. Yeah, so I would highly advise against spirals if you can. Spirals are very, very mathematical, and you can do them really easily in Rhino. Like, but that's Rhino, right? You can't really use Rhino for this assignment. I think if we just type in like spiral, yeah. So it's not like a. And I wonder if you can do that in Grasshopper, and I wonder if it's sort of counts. Whoops. So Grasshopper doesn't even let you do spirals, I don't think. Can you please share the definition of your example? Which ones? Because I think I deleted all of them. Were you like talking about these, Leila? I can share this script. I just can't share this because this is basically my whole assignment. Can you make all the walls have thicknesses at the same time? Yeah, I think so. This script sort of does that for all of this. So let's just hide all of this for a second and look at the curves that we imported. So let's select like a small subset of these curves. And we have to finish, oh, sure, okay. We have to fix a few things with grafting. So don't flatten that. Yeah, I think the goal is to have all the lines have the same thickness at the same, like using one sort of component, right? And not like this. To do that, set. Don't know why this isn't working. So that's another thing I am having trouble with today.
Is
What
it
did I
those
do here?
lines that you made? I'm not sure what it is. Like the ones after the curves with the start and end. No, those ones, yeah. No, with the start point and the end point.
Oh, these lines.
Yeah.
Yeah, these lines. Okay, so these are the curves. Wait, what? Because these are the curves I want. These are the endpoints, and I added an offset, so it looks like that. And I have endpoints connecting. Okay, something happened in this step. Something very wrong happened in this step.
The order, I think, is wrong. They have to have an order.
Oh, I think it's just the grafting issue here. This might be it. Okay, there we go. Okay, but it's still not sort of happy because, yeah, so I had to, it was a grafting issue. And grafting issues are sort of hard to explain, but it happens when you see like a big jumble of mess like that, then it's usually means that something needs to be grafted. In this case, it was these lines here. And I guess I don't need to graft these. So you have the curves which you merged into single curves. Then you join the curves, and you should have gotten not like that. Okay, that makes more sense. Singular curves. Then you use boundary surfaces. So it joined boundary surfaces. Then you added wall thicknesses. So I'll just go over this again because it was a bit confusing, I admit. So we have all of our curves, right, that sort of came in. Then we offset all of them. We didn't need to do any flattening or grafting at this point. And then we had the endpoints, right? The endpoints of our curves. So when you have endpoints, if we look at them, the structure is like, it's a flat list right now. And when we try to connect these endpoints to these endpoints, which are also, okay, so this is not a flat list. So if I just flatten these, does that mean I don't need to graft these? I'm still sort of figuring this out and my computer just froze. So that wasn't the right thing to do. Let's see if that still works. Okay, so it does make sense. So all I needed to do was make sure that my lists had the same structure. So if I connect a slider, a panel to this, so the endpoints here, I just connected a panel to the start points. So I can take a look at what the structure looks like, and I can tell that this is a single list, right? Because it doesn't have that division. But in this section here, before I flattened it, before I flattened it, so just unflatten that and take it. Yeah, so before I unflatten it, if I connect the start to this, because this input, this start input and this start input are going into the same thing, right? So it's this and this are going into the same thing. So they need to look the same or similar at least, right? But if you look at this and this, they do not look the same, right? There's like a bunch of these single item lists in here, and that's not the same. When this happens, what you need to do is make one look like the other. So I could have either grafted this, so now these look the same, and I would have gotten the same result. Or I could have either, I'm just gonna take a second to process, flattened this so that this looks the same as that. So if I flatten it, so if you think about it, flattening is like the opposite of grafting. And so if I were to graft this, I would have to flatten this. Does that make sense? Because they look different. So now they look the same. Everything is happy. I don't need to do anything else. Pretty sure I don't even, okay, I do need to flatten these curves here. So that's the other thing. When you're trying to join curves, when you're trying to join curves, you should flatten the input. But after that point, so that's all it is, really. Just make sure that your inputs look the same. And if something isn't happy, just look at the sort of what it looks for. And it, like in this case, curves just want to be flattened. So we just flattened that because it was giving us like a bunch of these different, yeah. So I hope that answers your question, Alyssa, how to add thicknesses and height to all of your curves together by offsetting them, getting the endpoints, connecting the endpoints, making these neat little rectangles, which are just the thickness, right? And adding a boundary surface to create like, excuse me, a surface, and then extruding that surface. Sorry, extruding that surface to create thickness. So the next question is, can you please show how you connect the columns to the floor plan? Columns to the floor plan. So if you mean like if you have the surface, let's say moved it onto this, and you wanted columns to connect to the floor plan. Okay, so sometimes nothing show up for me in processing despite having the code running. Like it's blank. Did you make sure to sort of not click this? So your visibility bar should just have this red shaded preview. If you click this, then it only shows what you selected. So that might not be what you want, Luis. Okay, so Youngber, if that's what you meant, then it's sort of simple. I mean, it depends on how you where you want your pillars to be. If the position of your pillars depends on the floor plan, then you just take that point, you project it up to the surface, and you connect it with a line. But if the position of your columns depends on the roof, so if the roof has like trusses and you need to connect those only the trusses to anywhere on the ground, then you just take points from the trusses and project it down. So it's a matter of projecting, but first you have to sort of decide where the columns are sort of, I guess, like where it starts, and it's usually a point. Show it with an example. I mean, I think I just did in here, but I'll do it again. So this was the example with the trusses, right? I'm just going to hide all of this. So this was the example with not this one. So these are the trusses, right? And our surface was like this. So that's the surface on top and the trusses. And let's say floor plan. Well, our floor plan doesn't really matter, right? The origin of our columns depends on the surface because we can't put a column like in here in this little area. The columns have to be right underneath each of these trusses, right? So if we get, let's look at our bottom points, and we'll get like every like second point. So I can use a call pattern to basically filter out every second or even third point from this list, right? So if I do a pattern that goes like true, oops, not like that. I can't press enter. So this is choosing every third point, right? So first, second, third, fourth. It's actually choosing every fourth point. So that sort of reduces the number of points we need to worry about to create our columns. You can also straight up call some of these trusses, but let's say these are the points, right? What we need to do is project to plane. So project onto a plane right over here. And the geometry we're going to project will be these points, and the plane we're going to project onto will be the XY plane. So that gives you basically these same points, right? But now flat. And using these points, so this point and this point, this set of points, connect them to a line, and you get straight lines or columns that connect your trusses. So if you look now at these, it's sort of hard to see without piping, but these columns touch the bottom side of the trusses exactly, right? And the trusses in turn, the top side of the trusses touch the surface. So maybe I will add a pipe. Not that one. Yeah, it's a bit too much. Yeah, so let's say these are the support. This is the support structure. So this whole thing will be your support structure, and the columns here don't necessarily have to touch your, like, interact with your ground, like your floor plan. It's better if they do. So if you have like a logic for, you know, creating columns exactly where you specified in your processing script, then you would do the reverse. You would start with the points on the floor, you project it onto the surface, and then you would also sort of create the trusses where those points are. So that's another thing you sort of need to worry about. But it's sort of up to you how you decide on putting or placing your trusses. Okay. Is there a way to make the extrusion round or close on the corners, because the wall corners don't meet completely after they're extruded? If you mean that they like these wall corners are, let's see where they do meet. Oh, like in this area here, there really isn't much you can do in this situation other than reverse the direction. So if I reverse the direction of my distances, then I fix the issue here, but I also introduce a bunch of issues. Or maybe I don't. Maybe I don't introduce any other issues. So try that. Try like instead of, you're adding your thickness, instead of making the thickness positive, just try making it negative. And if you're lucky, it might sort of, there is a situation where this would not work. I'm trying to figure that out. So it's this way. So yeah, so just try negating that value. Right? Actually. Yeah, so it right here. Oops. If you do, so it's sort of not possible to avoid these corners. You could extend the curve a bit, but that's just up to you how detailed you want to be in your script, and how sort of, how much time you want to put into making your project look good. Because this is fine, like it only happens in that one area in my like example, but for you, depending on your geometry, this sort of moment might happen in a lot of places. But it's up to you how you sort of deal with that. What I would do is sort of extend one of the offsetting curves a little bit, like by the amount I'm extruding, but that might, it's up to you. It's really particular. Yeah, so I really have to go, but there will be another sort of workshop. Hopefully I'm more prepared for that one and rested, but on the 15th at 4 p.m. All right, bye everybody.
Thanks everyone. Thank you, Sai.